Okay, cool. Let's get started. Functions. We're just going to build off of what we did on Monday's lecture. So briefly recap Monday's lecture, go into defining functions, how to call functions, and then the last 10 to 15 minutes of class we'll talk about the Wordle rubric, make sure that everyone gets all the points possible for the project. Any questions before we get started? Yeah.
Were we supposed to sign up for another tier thing to have our Wordle?
Yeah, so that'll be, I wanted you all to wait till today's lecture so you know kind of what you're going to be graded on, and you can go back and adjust stuff in your code if need be. But yeah, essentially through the end of this week and into next week, you'll be meeting with the Googler one time to get it graded. But this time, like, the code has to actually be submitted by Thursday night. I know at the check-in doc, it was kind of just you had to finish the doc before the meeting. This time we're going to make sure everyone's code is due on the same day. Okay, so recapping Monday's lecture, when we first started talking about functions, we used the example of a math function where we have an input x, it goes into the function f, and then we get a new output y, or f of x. In this example, like if x is equal to 3, x squared would be 9. But if we inputted that as 4, we would get a different dependent variable coming out, 16. So in the real world, we have similar examples. The one we talked about was a vending machine, where what did we say the input was for this kind of function?
Whatever number we have.
Yeah, so whatever like number the user types into the keypad, and then what would the output be in this analogy?
The snack that we get.
Yeah, exactly. The snack that comes out. Cool. So then converting that into computer science, we saw an example of the square root function, so this sqrt. In parentheses, the x is essentially our input. Does anyone remember what we call the input in computer science terms? Yeah.
Parameters.
Yeah, so the input is essentially our parameters, and then the output, what do we call the output in computer science? The return value. Why do we call it the return value? Yeah.
Because the function returns it to the function returns the value to itself after it runs.
Yeah, we're essentially like returning something back to whoever calls the function. So that's why we call it the return value. So in this case, the return value would be the square root of 25 or 81 or whatever the user inputs. Any questions here?
So there's a sqrt, is that actually like a function?
Yeah, so that's a function that exists in this like C math file. So we included C math, and then that lets us use the square root function.
Okay.
Mhm.
Cool.
In our class, we'll also be creating our own functions, but this is how you would call a function that already exists. Any other questions? Okay. So function definition. Does anyone remember some of the components of a function? Sure.
A return type, then it's the name of it, and then however many parameters.
Okay, so we said return type and parameters, so that's kind of the input and output. And then what does a function do?
Executes whatever in the function.
Yeah, it'll complete some specific task, right? So the function will be some block of code. It will take an input, or what we call parameters. It can, optionally. It will perform some specific task, and then it will return a value back to the user. Again, optionally, and we'll talk about these optional parts on Friday. All right, why do we use functions? 3 main reasons. It can make the code clear. So if we name our function something like calculate absolute value, or like if we were to do Wordle with functions, we maybe could have called one of the functions like color word, and it would take in a guess, and then it would print out that word with the different colors. And so that can just make it clear what the code is doing. You can reuse code. So if we created a function that maybe calculated interest over time for like money in a bank account, you could then do that with 100 different accounts with 100 different values just by calling that function name. You wouldn't have to copy and paste all the code a bunch of times. And then it's easier to do testing, especially with bigger projects. So you can test your small little function, make sure that it works before you plug it into the larger project. Any questions here? Today's lab is going to be practicing using functions and defining functions. And hopefully there you'll see why functions are useful. One of the problems I took was I took the soccer problem from the midterm where we calculate how many points a team has. But now we code that in a function, and then you can literally just take every team in the MLS and just plug in their wins and ties. And you can just have that be like 30 lines of code, and you could get all 30 points in their standings. Okay, so putting it fully in CS terms, the input is what we're going to call the parameters. The output is what we call the return value. Cool. Any questions on the recap portion? Okay, so now let's talk about how we would actually define a function or create our own function. So first off, what does this first word in the function header? We call the function header like this first line. What do we call this first word in the header? What does it reference? Yeah, the data type of what? Yeah, exactly. So we're essentially saying the computer needs to know what the inputs and outputs of this function is going to be. So we're essentially telling the computer with this first word, if anyone calls our function, we're going to give them back a double in this case. Or we could have made it a bool or a string or an int. But we have to tell the computer what our function is going to give back. So that's what we put first. What does this add word represent? Name of the function. So we could have called it anything. I just chose add in this case. You should choose a descriptive name for your function, and it will usually be a verb or some sort of action. Okay? And then what goes in the parentheses? The parameters. So that's kind of the inputs that we're expecting. Why do we put, so the num1 and num2, those are variable names that we create. Why do we also put the data type there? Yeah.
So that you need to specify the data type that the user is going to put into it.
Yeah, exactly. So the computer has to know, like if the user gave us a string here, we would tell, like the computer would print out an error. So it's kind of a contract. We have to tell the user that's calling our function what data inputs we expect, and then we'll tell them what data output we will give them back. So it's almost like a contract. And if either end of the contract is broken, the computer is going to throw an error. And so in this function header, we just have to be very clear, what data types are we taking in? What data type are we going to give back out? Any questions on that? Okay. In the function, so any code we write in here will be run if the user ever calls our add function. So we have sum is equal to num1 plus num2. Num1 and num2 are our inputs that we've gotten from the user, so we put them together, and then we return the sum. What would happen if we defined sum as an int here, and we said int sum is equal to num1 plus num2? Yeah, like the function is expecting us to return a double, so I think it would error. There's a chance because they're both numbers, maybe you would convert it. It might convert it to a double just without the decimal point. So we would check that, but pretty much your return type should equal whatever the return type of the function is. Yep. Okay, so I'm gonna have you all work in groups to create a function called isVotingAge. Essentially, we're just gonna take the user's age as input, and then we're gonna return true or false if they're 18 or older. So essentially, if they're old enough to vote. Okay? So you can use kind of this slide as a reference. Think about what your return type is going to be for this function is voting age. We all have you join up here with them. So Joe and John, we're together here. All right, you three together here. Yeah, so the function is going to be called isVotingAge.
No, what did you boy?
You're taking one input, which is the user's age, and think about what you're going to be returning in this function. Okay, so again, I'll put this slide back up. Think about what we returning true or false. Think about what data type that corresponds to.
And then age. So what you're saying that that's the parameter? The parameter is bool is voting age, age, and then in the function, it would do if statement check. If age is greater than 18 or greater than 18.
We have to assign to a player.
Return true.
Like if age is greater than if age is greater than equal to 18. We have to say that
Oh, yeah, shoot, I'm return true.
Let's have someone write it out, because I want to see where people are potentially. Remember when you create your function, you'll still have your curly braces? Indent your code. Indent your code.
Or you'll need an else statement. So if less than 10, then do that. You also just do the way that you do.
Yep. You can, yeah.
Oh, so.
False, nice. Your indentation looks good. The only thing is with C++, it's just bool, B-O-O-L, so you don't need B-A-N. Nice. Okay, cool. I think I saw a couple good examples in groups. Let's just go over it. Okay. So first off, what is our return type going to be for this function? Bool, because it's going to be true or false. So we have bool, function name. I kind of told you what to name it, but yeah, so we're going to go with is voting age. And then what are our parameters for this problem going to be? Int age, yeah. Cool. So now if we're to actually code this out, so what can we start off with in this code? Okay, an if statement, because we're going to be doing different things based on the different conditions. So if, and what are we putting in the condition?
Age is greater than or equal to 18.
Yeah, so if age is greater than or equal to 18, note that I put both curly braces, hit enter a couple times and indent it before I actually start coding in here. What do we want to do in this case? Yeah, so we can either store like true in a variable, or with return statements, you can also just return the value directly, right? You don't have to store it in a variable. You can just return it directly if you want. So we'll just say return true. All right, and then what do we want to do otherwise? Yep, so we would have like our else word. Else will return false. Yep. All right. Any questions on this function? Yeah.
So you can have multiple like return run.
So in a function, as soon as one return statement is run, the function stops and we exit. So as soon as we do like return true, we'll return true and then we exit the function. So in this case, it's if else, so both can still run. If we did something like this and we had like more code at the bottom, like do something else, like this code at the bottom would never run.
Okay.
Because we're either going to return true or we're going to return false. And then like we won't have time to like come here and do this stuff. So you can have multiple return statements, just if you have code after the return, it might not run. Yeah. And in this case, the reason why this one could run though is we won't always come into this if block. So there is a chance that sometimes we'd return false. Yeah. Good question. Any other questions? Okay, cool. I think people are having a good grasp of functions, which is good. So that's how we define or create a function. Now, if we want to actually call the function, so in the previous slide, we created the function, and we'll create it above the main function for now. If we want to actually call the function and use the code that we wrote, I'll give people like 30 seconds to think about it by themselves, but think about what line you would go here if we wanted to check whether a 16-year-old could vote. Think about it for like 30 seconds. Okay. Do people have ideas on what line can go here? Yeah, Sandra?
Would it be, can vote equals is voting age when in the parameters should be 16?
Cool. So, oh, I didn't put it in a duplicate slide. Okay, so in here, can't vote. So if we want to run the code that we wrote above, we just have to call it by its name. So we'd say, is voting age? And then in the parentheses, do we do something like this, like int 16? No.
You just
Just wrote 16.
Yeah, we can just put 16 here. So again, when we define the function, we have to say like what all the parameters are going to be and what the data types are. But when we actually call the function, we don't have to include the data types. We just say what the name is and we say what the values are. What would happen if we put the 16 in quotes like that?
It would.
Yeah, what would happen? Like what would happen?
It'd be an error.
Why would it be an error here?
Because parameters and put in a string.
Yeah, so the computer and the function is expecting an int, and so if it sees a string, it's not even going to run the function. It's just going to say there's an error. That's why when we define the function, we make sure to specify the data type. Yep. Okay. So let's see this in the code visualizer. Dang. Is anyone else having Wi-Fi problems? Is it just my laptop? Dang. Okay. Okay. So where did we define the function? We called it here. Okay. So include IOStream using namespace std. And we created this function, is voting age. I just copied this directly from the slides, what we created before. And so now, if we want to call this, we'll have, what did we call it here? We said bool can vote. And we said can vote equal to is voting age. And we wanted to check 16, right? And then we'll see out user can user vote. Okay. So let's run this code. Okay, note, what line are we starting at? 13. So we always start running our code at the main function. We create this bool variable can vote. What happens here at line 16? So first off, does the left side or right side run first? Right side runs first. So So the computer's going to see, is voting age 16? What is it going to do with that information? Yeah, it's going to think, okay, is voting age is a function, and it will go up and it will check, do we have a function called is voting age? So what line is going to run next? Line 4. So we come here. Note that we create a new memory box, right? So every time a new function is created, a new memory box is used. And so this memory box can't use any of the data here. And this main memory box can't use any of the data here. They're two separate memory frames. Okay? So what is the value of age going to be?
16.
Why is it going to be 16?
Because that's what you put in the parameter.
Yeah, so it's going to be a mapping here. So the first input we put here is 16. So that's going to map to the first input here, which is age. So this is, again, the third way that we've learned to do variable assignment. What were the other two ways? Yeah, so we just do the equals operator. We say index is equal to 0. That puts the value 0 in index. What's the second way we can do variable assignment? Cin. So we ask the user for some input. We cin that into a variable. And then this is the third way. It's by passing a value into a function, and whatever our parameters are, it will take on the value that we pass it. Okay. So age is going to be equal to 16. Is that greater than or equal to 18? No. So what line runs next?
Line 7.
Yeah, 7, which, because it's an else statement and we don't have to check anything, we'll go to 8. So we're going to return false here. What line is going to run next? Not quite 18. Close, though.
16 and it's going to do the left side.
Yeah, 16. So right now we've only done the right side of 16.
Oh, okay.
And what is this value going to be?
False.
False, because we're returning false. So this right side comes out to false. So we go to 16. Can vote is false. In computer science, bools are essentially stored as zeros or ones, where 0 is false, 1 is true. So it puts the value 0, which is equivalent to false. And so now if we say, can the user vote 0, which isn't a great output, we would want to convert that to yes or no, maybe. Okay. Any questions there? Does the kind of jumping between the two code paths make sense? And how values are being passed to one and then being returned back to the main?
Yeah.
Yeah? Okay. Cool. I'm trying to think if there's any other key things I want to show here. We were storing, let's create another one like int age is equal to 21. And we'll put it, so kind of like how we do, I think a concept that students still don't fully get is when we're trying to get the letter in the word and we do guess bracket index, and it's a little bit confusing when people see a word in the brackets when we're expecting a number. Why does it work for us to say like guess bracket index?
Because you're assigning a numerical value to it.
Yeah, so index is a variable that holds a numerical value. So when you see like the guess bracket index and that index is a value, that's like the same thing as saying guess 0 or guess 1, guess 2, guess 3, right? Functions are the same way. So I know in the examples we've been doing, we've just directly been putting a number or some input in here, but you can also put in a variable. So, and the variable name doesn't have to match. So like let's say, this is the bad variable name, but let's say it was like int x is equal to 21. And we wanted to check here, is voting age with 21? What can we put in the parentheses? Yeah, so we can put x. And the computer, when it sees x, is going to think of it as what?
21.
The value 21. Okay? So note that like x is not the same as age. But let's step through and see what happens. Okay, so now we have two variables in our main function. Can vote and x. What is x going to be equal to after line 16? 21. Okay, so the right side evaluates first. And the computer, before it even calls it, it's going to convert X. So the computer is really just reading that as is voting age parentheses 21. So what line is going to run next? Yeah, so kind of 4. We're going to go up to is voting age. And what is the value of age going to be here? 21. I think this is a really hard concept for people to get. Like, we call it X, and here we call it age, but the code still works. Right? Because the computer is just converting X to 21, and then it's just saying, okay, 21 maps to this input, age. Yeah? Okay. So now the code is going to run. Yeah, question.
Because both X and both age are parentheses next to is voting age.
Yes. So it's like the ordering of these, right? So is voting age and then the parentheses. So this is the first input in is voting age. So that just maps to the first input here. Let's say we had 2 inputs. We would do like X, comma, whatever the other value is. And in our function here, it would be int age, comma, whatever the next parameter is. And so the first one here would map to the first here. The second here would map to the second here. It's just like a direct mapping. Yeah, sure.
Yeah, so like the name of the variable that you put in the function when you're creating it, it doesn't matter. You're just using it as a reference for when the function needs to reference it within itself.
Yeah. Yeah, exactly. Like, we could have called this whatever we wanted. We could have called this X as well if we wanted to. But whatever we call this, that's what we're going to use inside the function. Yeah. It's almost like copying whatever values in the main function and putting it in our like actual function. Right?
But is voting age, that always has to be the same as both functions, right?
The names have to be the same. Yeah, so like you're saying like this is voting age and this is voting age? Yeah, that has to be the same so that the computer knows what line to go to. Yeah. Yeah, good clarification. So that's the one that has to be the same, but the input parameters don't have to be the same name. Yeah. Okay. Good. Any other questions? Okay, so if we step through, is this going to be true or false? True. So we go to line 6. We return true. What's going to run next?
Line 17.
Yeah, so 17, we've done the right half of 17 now. So is voting age is going to give us true, which is the value 1. And so we just have to assign that to 17. So can vote becomes 1, and then can the user vote, and we say what it is. Yeah. Okay. Cool. So there's going to be a lot of like small nuances like these with functions. And again, the best way is to practice. So we have lab 7 today. For this week, I'm actually going to take attendance for lab because I think this is the most important lab of the semester. Every code or project that we do from here on out is going to use functions. So if you don't understand functions and you don't get practice with functions, the rest of the semester is not going to be fun. So I'm going to make lab attendance mandatory for this week. I will actually take attendance. So make sure you come in either Wednesday, Friday, or Monday. Speaking of attendance, let me just quickly get attendance for this lecture today.
What time is the lab today? Is it 4 or 5?
5 p.m.
Okay.
5 p.m. today, 4 p.m. on Friday. Okay. Starfish. Okay. Alpha, Marshawn, Troy, Kadar,
Here.
Justin, Sandro, Aaron,
Here.
Christian, Fisher, Jacqueline,
Here.
Calvin,
Here.
Freddie, Matthew, Donovan, Christian Johnson, Kadar, John,
Here.
Jamel, Idris, later, John here, Troy Peterson, Mark, Rashad, Zach, just got chewed. All right. Sorry, wait. Zach, Ronald, Nehemiah, Andrew, Kalik,
Here.
Paul,
Here.
and Isaiah. Okay. So again, make sure you attend lab today, Friday, or Monday. Attendance will be mandatory for lab for this week. Yeah. Yep. Thanks for the reminder. Any other names I didn't call? Okay. Yeah, I'll get you, Omar. Thank you. Okay. Cool. So this is our code here. I'll put up the screenshot in the code. Yeah. All right. I'll put up the screenshot later. Okay. Final part for today. Wordle rubric. Okay. So I met with the other Googler TAs yesterday. We fleshed out the rubric. I'll go over the different components with you all today so that you can get full points for this project. So starter doc check-in. Everyone that's met with a Googler, I think for the most part, has gotten 20 points as long as you attempted the doc. We gave 20 points there. The other 5 categories. Code style. I have a slide for each of these points, so we'll go through what you need for each of them, but this is at least the point breakdown. Code style, testing, code comprehension. This point I kind of just consider as like general professionalism, and then code correctness at the end, for a total of 100 points here. Any questions on the breakdown before we get into the specific points? Okay. So code style. These are the 3 things we're going to be focusing on. So your variable naming. Do you choose names that make sense for your variables? If your variables are more than 2 words, does it use lower camel case? Because with variables, we can't have spaces in our names. So make sure that the first word is lowercase, and then the first letter of the second word and third word and so on is capitalized. Indentation. I have some examples on these next 2 slides. Looking at people's Wordle code, I still don't think indentation is quite there. So if you think you've indented it properly, but you want to get it checked before you meet with your Googler, just come and show me before or after class, right? And I can take a look and let you know if anything needs to be adjusted a little bit. And then finally, just add a couple comments summarizing parts of the code. You don't have to overdo it, maybe just 2 or 3 comments in your code, just summarizing maybe the outer while loop and the inner while loop, and maybe the coloring part. Yep. Okay, any questions on style? Yep, makes sense. So even if you finished coding already and your code works, go back and make sure that your style will pass and get these 10 points. Yep. Okay. So good code style examples. We have everything in the main function is indented 1 level. I use 2 spaces for my indentation level. Some of your code editors might use 4. Either is fine. Just be consistent. So everything in the main function is indented 1 level. You'll note this closing brace lines up with this main function line. Then next level, this while loop. This closing brace lines up with this while loop. Everything inside the while loop is indented another level. So we have 1 level of indentation for the main function, 1 level of indentation here for this while loop, right? Then we have an if statement in here. Notice this bracket lines up with this if. This bracket lines up with this else. Everything inside the if and the else are indented. So at line 11, we have 3 levels of indentation, right? We have 1 level for the main function, 1 level for the while loop, 1 level for the if statement. Any questions on indentation? Yep. Okay, and then in this problem, this was calculating the product using while loops. Notice that we have descriptive names, so we have the number, we have the n number. Product is what we're trying to build out. N number is 2 words, so I used lower camel case, where the first word is lowercase, and then the n is capitalized. And then I just put a couple comments, so ask user for starting and ending number. And then I kind of said how we're calculating the product. It's number times number plus 1 times number plus 2, all the way up to n number. Okay. Any questions on style? Cool. At larger companies like at Google, you can't submit code unless you pass all the style checks. The reason why style is important is we want consistency. So when other people read your code or make edits to your code, everyone is on the same page for generally how it should look. So these are best practices that no matter what company you go to, these are the baseline that you need. Indentation, good variable names, comments. Yeah.
So it's not a certain way to do it, you just hit the have it need? Does it just have to be the need? For a person to be able to read? Or?
So part of what making it as neat is using this indentation style. So that's a standard almost, the indentation, yeah. Okay, testing. So I just added a new slide in EdStem last night. We'll see if this loads. But if you go to your Wordle project, you'll notice in the second slide, there's a slide called Wordle testing. Sweet, it's loading up here. Okay, we want people to be intentional thinking through how they're gonna test their code. So I guess there's actually 6 scenarios now for each of the scenarios below. Okay, so we want you to be specific. So let's do like this yellow one together. So the way I'd set up this test, generally speaking, would be like have answer equal. Can someone give me like a 5-letter word? Horse. Okay. And then run code. Have user type in first. Have users first guess. Okay. Like we'll say like on first guess, user types in, and what's a word that will have at least one of the letters being yellow? Yeah, so we'll do like, I'll do shade just so that every letter is distinct. We don't want to have stuff with 2 letters here. Okay, so now we would say like the output should be, and what should it be? So we have S, the S is going to be yellow, right? H, also sorry, these are lowercase, I guess. Right, and then I guess the A is red, and so on, but you know, you would do the rest of them. D is red, E is green. So, and then we'd say, like, if our, like, we know our code works if only the S and H are marked as yellow, right? Do people kind of understand how we set up that test? And how it makes sure that we only mark the S and H as yellow. If like something else like the D came out as yellow, that would still be an indication that our code isn't properly working, right? So you'll fill out this slide. It's just 6 questions. And then when you meet with your Googler and you present your code, then you'll walk them through it. So you'll say like, this is my code. If we run it and we want to make sure that the yellow letters are working, we'll try typing in the word shade. Then if we want to make sure that a letter is red, you could maybe even copy this same example and say like the A and the D should be red, right? But we want you to think about this before you actually meet with the Googler. That way when you meet with the Googler, you can then show them you've thought about it and then show them that your tests work. Any questions here? Make sure you hit submit on these as well. Okay. So even if you've already finished your project, make sure you go back and you fill out these boxes for Wordle testing before you meet up with your Googler. Yep. Okay. Third part, code comprehension. So after you run your code, you walk through your test cases with your Googler, you show them that your code works. Then the Googler is going to ask you how your code actually works. So if this was like your output, they might ask you, okay, where in your code, what line number are you asking the user to enter their guess? Right, and then you'll be like, oh, on this line inside my outer while loop, every time the loop runs, I ask the user for a guess. Then they'll ask you, okay, how do you get on the first guess, how do you get the letter B, and why did you mark it red? And then you'll kind of show them like on this line in the code, I say guess is equal to, or letter is equal to guess of index, that letter gives me the B, and then we check if letter should be green. It's not. Then we check if it should be red, right? We just generally want to make sure that you understand what your code is doing. So if you wrote your code and you understand it, like you shouldn't have to like prepare for this. It's not like we're gonna throw trick questions at you. It's just making sure that you understand your code flow. Okay. Any questions there? Yeah.
Do you want our code to say how many guesses they have left?
You don't have to. I just copied from one of the students' code and they happened to do it. But yeah, that's not required. Okay. Any other questions on this part? Okay. Effort, communication, punctuality. Essentially, I just boiled this down to professionalism. So was your code submitted on time? Again, everyone's code needs to be submitted by Thursday. Or you can communicate with me and say if you need an extension when you'll have the code ready by. But that kind of falls under the communication part. All right, did you get help at office hours or over email? Or if you didn't need help, did you try a stretch opportunity? when I was reading through people's like participation grades that they gave for themselves, some students said like, I don't really come into office hours because I understand the material. Like, excuse me, that's fine. Like if you understand the material, you don't have to come into office hours for the sake of office hours. But I would want you to try a stretch opportunity if you feel like you already understand everything. So there's like two ways to show effort, right? Either if you don't fully get it, you come in and get help. Or if you do get it, then you push yourself and you try a stretch opportunity or you do a bonus problem, right? So you don't have to ding yourself for effort or participation if you don't come in for help, just as long as you do some of these other things. Does that make sense? Okay. Okay, and then generally, like, did you attend your Googler meeting on time? Were you prepared when you presented your project? And then is the work your own? Like, do you feel proud of what you accomplished? Yep. Okay. Yeah.
Oh, where do we submit our Wordles to? Just in the Scratch?
So yeah, good question. If you're using the Scratchpad, make sure you move everything to this first Wordle slide, and then just hit the submit button. Yeah, so good point. If we're gonna look at your last submission, so really make sure if you've been working in like Wordle Bonus and Wordle Scratchpad, once you know you have a working version, like put it in this Wordle doc and hit submit. This is what we'll be using to keep track of when people submitted. Yep.
So if we do the bonus, should we print it in the Wordle one? Or
I guess just submit in both. So like submit maybe your normal. Yeah, okay, or submit in both. If you just have one copy of your code, like submit it in both. Yeah. Okay.
So you want us to submit it like this Thursday, tomorrow?
Yeah. Yeah. Okay. And then the final part is just code correctness. So does your code work? Right. There shouldn't be any surprises. Like all the test cases we're going to be checking. It's listed in that testing slide. So literally just test all the scenarios there, and you should know if your code works or not. Right. Okay. So a lot of information. These are kind of the 5 action slides, or 5 action items. I'll post up the slides, but I'd encourage you to take a photo of this as well. Complete the testing slide. Make sure your code is styled correctly. Make sure you hit the submit button. And then before you meet with your Googler, just know how your code works. Meet with your Googler on time. Yep. It'll say either submit or mark, I believe.
Just on the Wordle testing?
So both. So like the Wordle testing slide, make sure you hit submit for each button, but then on the Wordle slide, the first one, that's where you'll submit your code.
Well, I put it on like where some Wordle scratch.
So that's fine to like work on it there, but once it's working, copy and paste that into your Wordle slide and hit submit there, because I'll be just looking at the Wordle slide for submissions. Okay. Any questions? Feels like a lot of information. I just want to give you the information so that you know how we're grading you. There shouldn't be any surprises, essentially, on what grade you're going to get for this project. Yeah? Okay. Wordle support. So again, it's due tomorrow night. Come in today, 3 to 6 p.m. So 3 to 5 will be in my office. 5 to 6 will be here in lab. I'll mostly be helping people with Wordle during lab, and Trey and David will be helping the people actually working on lab with the function stuff. So come in anytime today, 3 to 6. David has office hours tomorrow from 2:30 to 3:30. You can also email me tomorrow if you have questions. It'll be much faster if you come in today and get in-person help, right? It's slower to do stuff over email, much faster to get help in person. Kadar.
I'll also be here after class.
Cool, thank you. Yes, Kadar can help out as well. Yeah, there's a lot of support. Make sure you take advantage. You can also, if it's just a coding error, I can help over email, but if you have no idea how your code is supposed to be set up, then set up a meeting with a Googler by Thursday, right? Okay, so what's due? Lab 6, due today. Wordle code due tomorrow. And then STEP internship, if you're interested, try to apply by this week. All right, any questions? Cool.